Now, welcome to another tutorial of Proplan. Sometimes you've seen a question whereby when your teacher is teaching you and the teacher tells you that when resistors are arranged in series, and suppose this is R1, R2 and R3, in this case the teacher will tell you that total resistance will be R total will be equal to R1 plus R2 plus R3, so that you can be able to get the effective resistance. So I'm going to show you how this formula is arrived at. So we are going to talk about resistors in series. When we are talking about resistors in series, what we mean is that they are connected next to each other. So what is really uniform for this case, current is the same throughout. The current that is passing through all these resistors is the same. And we're going to say therefore that the voltage drop across this resistor, for instance, we can be able to say if these resistors are connected to a potential difference or an EMF are connected to an EMF V, then we're going to say that current that is passing through all around is the same. So meaning that voltage from Ohm's law V equals to IR, right? So the voltage drop for this, the voltage across this resistor plus the voltage across this resistor plus the voltage across this resistor will add up to the voltage that was being supplied. So that means that we are going to say V1 is going to be for the voltage across resistor 1, so it will be current times R1. V2 will be voltage across this second resistor, which we are going to say I R2, and the last one is V3 is equals to I R3. But from Kirchhoff's law, the potential drop across all the components will add up to the EMF that was being supplied. So the voltage that was being supplied is V. So meaning we are going to say therefore V is equal to 1, V2, V3 are these values that we have obtained at this point here. So meaning we are going to say this is V is equals to I R1 plus I R2 plus I R3. So you see current is the same through every component in series. So we can be able to factor I out. So we shall have V is equals to I into R1 plus R2 plus R3. So you can see now we have our resistor values there. Divide by I, this will cancel out. Since this was the total voltage and this current that we are talking of, I, is the total current that was flowing through the circuit, it means that V total divided by I total, then that will mean that this is the resistance in the entire circuit. R total is equals to R1 plus R2 plus R3. So anytime you are given resistors which are connected in series, what you are going to do is that you are going to add the total resistance. You're going to add all the resistors together so that you can be able to get the combined resistance. So in this case here, you can be given resistors which are connected like this: one resistor, another resistor. So this is 4 ohms and this is 5 ohms. Then total resistance in this connection is going to be 4 plus 5, which is equivalent to 9 ohms. So basically the resistors are connected in parallel like this. What we need to understand, for all these components in parallel, they are going to have the same voltage. This will have the same voltage, this resistor 2 will have the same voltage, and resistor 3 will have the same voltage. But the current that is coming from the source is going to be shared to all this component that is there. So the current in resistor 1 is different, current in resistor 2 is different, and current in resistor 3 is different. So we are going to say that from Ohm's law, V is equals to IR. From Ohm's law, V is equals to IR. So meaning we can be able to rearrange this equation and show that the total resistance is going to be what R total is going to be 1 over R1 plus 1 over R2 plus 1 over form. In that case, you need to understand that when these components are connected in parallel, they are going to have the same voltage. R1 will have the same voltage, R2 will have the same voltage, R3 will have the same voltage, but current is going to be shared. If this is the total current in the circuit, this one is going to get R1, this one will get R2, this is going to get R3. So therefore, from Ohm's law, we know that V is equals to IR. So this implies that we can be able to say current is equals to voltage over resistance. So if we want to get the first current here, current I, current number 1, current first I1, we are going to say I1 is equals to voltage is going to be the same for all the components in parallel. So this is going to be V over resistance R, V over R. R here is our R1. And the second current 2 is going to be V over R2. And also we shall have I3 is going to be equals to V over R3. Then now we say that all this current that is branching at this given point, if you add from Kirchhoff law, I is equals to I1 plus I2 plus I3. Current going into the point is equal to the current going out of the point. So this current, all the three added, will give us the current, because you see this current will pass here, will just join up. This current going will go up like that, this current will go up, so we shall have the current I flowing through the circuit. So meaning that I is equals to I1 plus I2 plus I3. Are we together up to that point? So meaning that I1 is represented by V over R1. So this is going to be I1 is, no, this is I is equals to V over R1 plus V over R2 plus V over R3. So meaning we can be able to factor out V. You can see V is the same throughout. We can say that this is I is equals to V into 1 over R1 plus 1 over R2 plus 1 over R3. So with this, you can see we can divide both sides by V. Divide by V, divide by V, so that this will cancel out. We are going to remain with I over V is equals to 1 over R1 plus 1 over R2 plus 1 over R3, like that. But you see, resistance is V over I. If you are having I over V, that means 1 over R. So since this was the total voltage and this is the total current, if you are dividing total voltage and total current, it means you are going to get the total resistance. And since this is I over V, so it will be 1 over R, because R is equal to what? V over I. So it's a reciprocal. So which means that this part that we have here can be able to be written as I over V is the same as 1 over R, which is going to be our total resistance is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. So basically that's what you do whenever you are given resistors in parallel and you are supposed to prove that concept.